So now ionic compounds. What are ionic compounds? The compounds which are made up of ions are known as ionic compounds. That means an ionic compound contains ions, positively charged ions or negatively charged ions, cations or anions. So in an ionic compound, we are having positively charged ions, cations, and negatively charged ions, anions, and they are held together by strong forces of attraction, and those forces which hold the ions together in an ionic compound are known as ionic bond or electrovalent bonds. Now, since an ionic compound consists of an equal number of positive ions and negative ions, it means if there are four positive ions, there would be four negative ions. So, the overall charge of an ionic compound is zero. Let's have a look on the ionic compound of sodium chloride. It's an ionic compound because it is made of positively charged anion, cation, and negatively charged anion. So here we are having Na positive, that means positively charged sodium ion that's combined with the negatively charged chloride ion. Some other examples of any compounds are copper sulfate. You are having positively charged 2 units of positive charge of copper and 2 units of negative charge of sulfate ion. See, number of cations are 2 and number of anions are also 2. That means the number of positive charge, positive ions, and the number of negative ions, that is equal, and overall the charge of an ion is 0. Calcium nitrate, you are having 2 positive calcium ions and 1 negative, sorry, it's 2 negative, NO3 is here 2 negative, sorry. So 2 units of positive charge and 2 units of negative charge. So overall charge of an ionic compound is 0. Now we see that the ionic compound is made of metal and non-metal, except ammonium chloride. Ammonium chloride, that is NH4Cl. It's an ionic compound, but that is made of only non-metals. Ammonia and chloride, both ammonium and chlorine basically. Ammonium is also a non-metal, NH4. Chlorine, Cl, is also a non-metal. So every ionic compound is made of metals here. Calcium is a metal, nitrate is non-metal, sodium is metal, chlorine is non-metal. So every ionic compound is made of metal and non-metal except ammonium chloride. Ammonium chloride is an ionic compound, but ammonium chloride is made of only non-metals. Ammonium is also a non-metal and chlorine is also a non-metal. So whenever we see a compound that is made of a metal and a non-metal, and we at once whenever you see a compound made of metal and non-metal, then that is an ionic compound. Now let's if for discussing the formula mass, we should know the meaning of a formula unit of an ionic compound. So an ionic compound, see, here I am having an ionic compound of sodium chloride, and ionic compound is made of extremely large number of positively charged ions and negatively charged ions joined together. If you see sodium chloride, it's an ionic compound and it consists of a large number of sodium ions, Na positive, and chloride ions, Cl negative. But yes, both the number of sodium ions and chloride ions are equal. If we look at the formula for sodium chloride compound, because there are having number of sodium and chloride ions, then the formula should be Na plus Cl negative. But how many Na positives? N. The formula should be NaN. N number of atoms, ions. Cl negative, N. N number of chloride ions, where n is actually the large number, because an ionic compound contains large number of positively charged ions and negatively charged ions. But we write the formula for this ionic compound as NaCl, right? We write this formula, Na plus and Cl negative. So this is the simplest formula of sodium chloride, but not its actual formula, because actually it contains large number of sodium ions and chloride ions. So the formula should be Na positive n times n number of atoms and chlorine negative n times n number of atoms. But we write the simplest formula, NaCl. That is not the actual formula. So the simplest combination of ions that produces an electrically neutral unit is known as formula unit. So what we have written here, that is Na positive Cl negative, formula NaCl. That is the formula unit of an ionic compound. That is not the actual formula, it is the formula unit. You are showing the simplest combination of ions, and this combination produces an neutral unit, because one unit of positive charge and one unit of negative charge will balance each other, so the overall charge will be zero. Same goes for every ionic compound. Every ionic compound is made of large number of positively charged ions and negatively charged ions. But when we write the simplest formula, see, you are writing here the simplest formula, copper sulfate. So this is not the actual formula, this is the simplest formula, and this is known as formula unit. Okay. Now, ionic compounds, they do not consist of molecules. So that is why the term molecular mass for them is not very correct, because we do not because ionic compounds do not consist of molecules. So instead of molecular mass, we use the term formula mass for ionic compounds. So actually, molecular mass and formula mass is the same thing, but just because the ionic compounds do not consist of molecules, so we use the term formula mass for ionic compounds. And in ionic compounds, individual molecules do not exist, right? So the formula mass of an ionic compound is the relative mass of its formula unit as compared with the mass of carbon 12 atom taken as 12 units. Same as the definition of molecular mass, but yes, instead of molecular mass, we are having here formula mass. Again, see, molecular mass was the sum of the atomic masses of the atoms, right, represented by the formula. Here we are having the formula mass, and that is also the sum of the atomic masses of the ions represented by its formula. So the formula for the formula of an ionic compound, sorry, for the formula mass of an ionic compound, we should know the formula of an ionic compound. Then we should know their atomic masses. Then we can calculate the formula mass as we calculated in the molecular mass. And yes, mind it, the atomic mass of an atom and its ion is same, because the electrons which convert an atom into an ion have negligible mass. So that is why the atomic mass of atom and ion both are same. So let's calculate the formula mass of potassium carbonate, that's K2CO3, potassium carbonate. Now see, it contains potassium ions as well as carbonate ions. So how can we calculate its formula mass? First of all, we have to calculate the atomic mass of potassium. And how many atoms of potassium are present? 2 atoms. So we need to find the mass of 2 potassium atoms. Plus, because we know formula mass is equal to sum of atomic masses. And then how many carbon atoms are present? 1. So mass of 1 carbon atom. How many oxygen atoms are present? 3. Mass of 3 oxygen atoms. So see, 2 as it is. For mass of 1 potassium atom, that is 39, plus mass of 1 carbon atom, that's 12, plus 3, because we are having 3 oxygen atoms, multiplied by how many, what is the mass of oxygen? 1 atom of oxygen, that is 16. Then that gives us 138 units. So the formula mass, this is same as molecular mass, but yes, here the term is formula mass, and that is the formula mass of potassium carbonate is 138 units. So this was all about the formula unit and formula mass. Thank you.